Hey class, we want to look at one last idea on these properties, and we're going to look at something called the even and odd property. So if we think of a cosine of theta and then a cosine of negative theta. So look what happens here. Remember, the cosine is the x coordinate, and if say for instance 60 degrees or pi over 3 is theta, our angle, and then we get cosine of theta in that case, it's equal to 1/2. Now let's pop down here and go negative theta. So 300 degrees or 5 pi over 3 is the same as negative pi over 3 or negative 60 degrees. And you also see that it has the same cosine. So the cosine of negative pi over 3 is also equal to 1/2. Okay, and if you think about it, it makes sense because the cosine comes from x, and in quadrant 1 and quadrant 4, x is positive. So what we can conclude from this picture and the logic here is that a cosine of negative theta is equal to a cosine of theta. Okay, so now let's look at that with just a couple of the others. Let's take a look at a sine. And since we've already used pi over 3, let's look at it for something different. Let's look at a sine of pi over 6. And if I look at the sine for pi over 6, it's the y, so it's 1/2. But when I drop down here, if I ask for the sine of negative pi over 6, which is equivalent to 11 pi over 6, if I go all the way around here, or just come shy of a full rotation, it's 11 pi over 6, but then negative pi over 6 takes me to the coterminal angle there. So the sine of negative pi over 6 is going to be negative 1/2. Okay, and so this is what we call even behavior, and this is what we call odd behavior. So sine of negative pi over 6 is equal to the opposite of the sine of pi over 6. Okay, and so we're going to generalize those ideas. Now let's do it with tangent real quick. What works for tangent? So, okay, so looking at this, what do we think is going to happen? Is tangent going to be like cosine or like sine? Well, if we think of tangent, remember that it's y over x. And so I have a positive over a positive, but down here I have alternate signs. So I have a negative over negative. So that's going to put us in this odd territory. So the tangent, let's just use pi over 4 as our representative angle here. The tangent of pi over 4 is equal to, let's do it like this. Tangent of pi over 4 is equal to 1. Okay, because this number divided by itself. But the tangent of negative pi over 4 is equal to this number in the negative divided by the same absolute value. So that's a -1. Okay, so that we can see that it's got that odd behavior, and a tangent of a negative theta is equal to negative of a tangent of theta. Okay, and so for sine, we got that same thing. Generally, what I would say here, I locked it into this one angle, but we look carefully, we can see that a sine of any angle, sine of the negative of any angle is equal to a negative of the sine of that angle. Okay. All right, so we can use these identities and do substitutions. Okay, so here we have a summary of the even and odd properties. So it's considered an odd function if the sine of negative theta is equal to the negative sine of theta. So just in general, if we have a function f of x, well, that's not what I want. So if we have a f of negative x that always evaluates to negative f of x, then we call that an odd function. Okay, so we see that behavior in the sine, the cosecant, the tangent, and the cotangent. But if we have f of negative x always evaluates to the same as f of x, then we call that an even function. And we see that behavior with the cosine and its partner inverse, the secant. Okay, so let's use these. All right, if I want the sine of negative 30 degrees, and I know that that's equivalent to negative of the sine of 30 degrees. So if you're getting pretty used to this by now and you can do them off the top of your head, that's good. So the sine here would be 1/2. So the answer is going to be the negative sine of 30 degrees, so negative 1/2. Okay, cosine was even, so we know that this is equivalent to the cosine of pi over 3. Okay, and if you consult for the x coordinate of pi over 3 intersect point, you'll get 1/2. And then the cotangent, so remember that the partner functions inherit the even or odd nature of the inverse. So in this case, it's going to be equal to negative of cotangent of 5 pi over 4. Okay, and so that's going to be equal to negative square root of 2 over negative square root of 2, negative square root of 2 over 2 divided by a negative square root of 2 over 2. Okay, so this actually comes out to be positive 1 because it's a negative divided by a negative. But remember, we're putting this negative sign in front of it. So it goes back to negative, and that'll be a negative 1. Okay, and then with this tangent, it was also odd. So we put the negative out here on the outside. We have 29 pi over 4. And then remember that every pi in the tangent or the cotangent, every distance of pi is a cycle. So we'll write this as a negative tangent of 1 pi over 4 plus the 28 pi's over 4 that are left. And 28 divided by 4 is 7. So we'll just write those at 7 pi. Okay, so this is all just taking us back to the same place. All we really care about is tangent of pi over 4. We've got this negative in front of it still, so negative tangent of pi over 4 is our result. And the tangent of pi over 4 is positive 1, but the negative here tells us that the tangent of negative 29 pi over 4 would be negative 1.